All right, everybody. Break's over. Come on back. Get your cameras on. All right, so what I want to talk to you guys about now is the steps we do to actually solve the control system problem. So you can imagine your employer, your boss would come to you with a narrative, a description, a verbal description of what the problem is, and you have to turn this into a working control system, right? And basically, it's going through a number of steps. The first step is he would describe it, and you have to disseminate what he actually described. Then you have to look for all of the outputs that are required, right? Things like motors and lamps and alarms and those things. You have to define all the outputs. Then you have to look at all the inputs that he's asked for, things like switches and limit switches and sensors and things. All those input devices have to be clearly defined and named. And then we do a Boolean equation that defines the relationship between the outputs and the inputs, right? And from the Boolean, we would take that to a control system. We'd actually build our ladder diagram from that Boolean expression. So here's what I'm going to do. Let's say that we have got a very, very important, well, I'm going to share my screen here. Hold on. Am I sharing it? No, I'm not. There we go. Or am I sharing it? Yes, I am. So let's go back to the Jamboard. And I'm going to copy that into the chat again. There's the Jamboard. And here is our problem, right? Our problem is there's a guy named Whitby Warehousing, and we got to design a control system for his goods lift. He's got this little, it's like a dumbwaiter, right? It's not meant for people. It's a little box that goes on the wall. You put stuff in it, you close the door, you press up, the dumbwaiter goes to the top floor. And on the top floor, the guy can open up the door and pull the things out, right? Put something else in, close the door, push the button, and it goes down. So it's got a reversible electric motor, gate switches, normally up and down. So it's got all of these things. And here is his criterion for how he wants it to work, right? He's got this criterion for how he wants it to work. Now, what I'm going to do is I'm going to break you guys into four breakout rooms, 4 or 5 breakout rooms. And in those breakout rooms, I want you to use your page on the Jamboard. You notice I've got design room 1, 2, 3, 4, and 5. So each breakout room is going to be breakout room 1, 2, 3, 4. You go to your own design room on the Jamboard. First thing I want you to do is sketch a picture of what this thing looks like and where the inputs and outputs are, where the motor is and what the input for the motor is and what the output for the motor is and all that kind of stuff. And be able to understand what it is that Whitby wants this thing to do, right? So you got to think about all the kinds of inputs it has and outputs, and then do a technical drawing as best you can using the text here, the little text tool. And you got this little tool here, you can draw circles and things with this, right? And then sketch this, define how it works in your head. Does anybody have any problems about what you're expected to do? Okay, I'm going to put you guys into the breakout rooms now. So we'll spend 15 minutes looking at the problem and then trying to define the inputs and outputs and your expectations on what this thing's going to look like, right? So do those technical drawings as best you can. By the way, the description's in page 1 of the Jamboard. So you can go to page 1 and get it there. All right, guys?
Okay, yeah.
All right, you work together, you guys. We got 15 minutes. So the Jamboard's on page 1. Page 1's got the description on the Jamboard. Okay. You guys have any questions on what you're doing?
I think it's straightforward.
All right, good enough. So keep in mind that the description that for this system is on page 1 of the Jamboard if you need to get to it.
Yeah, no, I think we're okay.
All right, good man.
Yeah, so we got a down button and an up button. And we're gonna need a sensor. I'll use a diamond for the sensor that tells me when the gates are up or down, because
Hey guys, just so you know, the description is all on page 1 of the Jamboard. Okay?
Yeah. Okay.
All right. You guys okay with what you have to do?
Well, kind of. This is all pretty new to me, so I'm not really.
Well, look for inputs and outputs and understand what the system is asking you to do, right? What the narrative is trying to describe to you here. Okay. And sketch a image on that Jamboard as best you can. That kind of is a technical drawing of what they're asking for.
All right, give it a shot.
Alrighty.
worry about that right now. Just I would just focus on just considering it motor going up is one set of contacts and motor going down is another set.
Yep.
Okay.
Yep. Good. This works. This works great, guys. You're deconstructing the problem into a circuit elements, which is what we want to see, right?
Yeah.
And you're giving those circuit elements a name, like some kind of a symbol or a name to describe
Oh,
them.
yeah.
Which is
Yeah, we
also
just
what
have a
you
set
want
of
to see.
letters. Yeah,
You're-
we just
you're
have a set of
already in
letters
that.
for each one.
What's that?
Oh, I just said we have a set of letters for beside each one, which we're using to represent it.
Yes.
So the down button becomes DN and then
Yes.
so forth there.
Perfect, because that'll go nicely into a Boolean expression. All right, good. I'm going to go check out the other rooms here.
Yeah.
That should be the main, right? Because because you already did the one at the
Yeah.
top.
Yeah.
That one. He's in here.
Yeah, that's looking good, you guys. So you got your different elements. You want to take all your input and output elements and give them names. So you're deconstructing the narrative into a bunch of circuit elements, right? Like motors and push buttons and limit switches. And you're giving them all some kind of a little name that you can use in the Boolean expression. That's what we're shooting for here, right? Does that
Okay,
make
that makes sense. So we could just start to collect names for the different inputs and outputs.
Yeah, because I see you got a limit switch on the bottom and limit switch on the top. So give them a name, limit switch upper, limit switch lower, or LS, whatever. You got a break. You can call it break or BRK. You got a up button and a down button. I think, is there one on each floor or is there just one up button and down button?
There would have to be one on each floor, so you could bring it up if you were above.
That's right. So you got a couple of them. I think with this, you can copy and paste. But so you'll have a couple of push buttons. So we're trying to see what we're doing is deconstructing the narrative the boss gave you into the circuit elements, the motors, the limit switches, the push buttons, the brakes, all the electronic things we're working with, right?
Okay, that's easy.
And then later on, we're going to turn them into Boolean expressions. Okay.
Okay, we'll
Okay.
work on that. That makes sense.
All right. You just keep doing this. And this is a great way to really understand what the problem is. So good work, guys.
Brady, you want to be the scribe?
Okay.
Or-
Uh-huh.
This is working really well, you guys. This is looking good now. So you're starting to get the idea. So what we're trying to do is take the narrative that's been given to you about how it works, and we're deconstructing it into all the circuit elements, the upper limit switch, the lower limit switch, the push button up, the push button down on the top floor and on the bottom floor, and the brakes and the motor up and the motor down. So we're trying to find all these circuit elements and we're going to give them names, right? You've got one called upper, one called main, an M, and LS. You got two of them called LS, so maybe LS upper and LS lower, or LSU, LSL, whatever you want. So that's what we're shooting for here, to really understand what the problem is. Does that make sense, you guys? Francis? Herman, sound good?
Yeah,
Okay,
thinking.
all right.
Thank you.
And you can look or check the other rooms out and see what they're doing to give you some ideas. Room one's got it pretty good, except they're going ahead and doing the Boolean equations. You don't have to do those yet. We're going to do those in a minute. So, all right, good work, you guys. Hey, Chris and Jessica, this is looking better. This is looking really good. So what you're doing, basically, you there? You guys there?
Yeah, sorry, my thing was hidden behind some pages.
Okay, yeah. So what you're doing is you're taking the narrative described to you in that little thing you cut and pasted here, and you're dissecting, you're decomposing them, you're deconstructing them into all the electrical and mechanical elements in the circuit, right? So you got your upper limit switches, your lower limit switches, you got push buttons in the top, push buttons in the bottom, you got a motor up and a motor down and a brake and all those things. And you're also trying to give them a name, you know, a simple name that we can use in a Boolean equation, simple, like PB up, PB down, you know, or whatever you want to call them. So we're going to define them into simple names to describe all these elements. Does that make sense?
Yeah.
Do you understand how this little dumbwaiter works?
Yeah.
Okay, no questions?
So just give them names that we can use with Boolean logic.
That's right, because I see you've got limit switch, but you're using limit switch twice, and that implies it's the same limit switch. So you might want to call the top one LSU for upper and LSL for lower, or whatever you want to call it, LS up, LS down, right?
Okay. Yeah.
Yep, and brakes. So there must be an input for brakes, right?
Yeah.
All right. I'll give you about 5 more minutes. Is that enough
Sure.
time?
Yeah.
All right. This works. All right, welcome back, everybody. So you guys have had a good long period of time to look at the narrative. Do you feel that everybody understands the situation here? Everybody understands how this dumbwaiter works and how the push buttons are set up and what the brake does, what the motor does. You guys all good on that? Anybody have any ambiguity? This is the time in the design process that you nail down any confusion that you have. Because if you're confused now and you wire it into the control system, you're going to have a very confused control system. Does that make sense? Okay, so does the unit have motorized doors? Doesn't sound like it. I never heard anything about a motorized door. So I'm assuming that it's probably like a panel on the wall where you open up the door and the limit switch at the gate tells you the door's open. Then you can put your crap in the door and then you close it and push the up button, right? What happens when you push the up button? Anybody?
Well, that depends on if you did your job right.
All right. So if it's yeah, right. If it was,
Well,
if
it
you did
depends
your
if
job
the
right,
doors are
if you
shut.
did your job right, and I'm on the lower floor and I put some crap inside and close let's say I leave the gate open and I press the up button, what should happen?
Absolutely nothing.
Absolutely nothing. So I'll close the gate, right? And I'll push the up button. Now what's going to happen?
The brake has to disengage and the motor has to pull up.
So there'll be a motor up that'll pull the motor up. Yeah. So it's going to go up to the top floor and it's going to keep going up to the top floor till it gets to there, right? And then it will
Hit the
what'll
limit switch and stop.
then it'll stop.
Break.
Right. We don't want it to like go right through the roof. Motor will stop when it gets to the top floor. And hopefully somebody up there will open up the door, and take the stuff out. And if a guy opens up the door before the elevator gets there, what does it imply the elevator will do?
Stop.
Stop for safety's sake, right? It'll just stop. And if it's, I didn't see anything in there that has an interlock that locks the gate, right? So I'm assuming that the guy can open it when it's halfway up and halfway down. If there was that condition, if there was some kind of a little interlock on a solenoid that went into the gate to lock it when it's moving, yeah, we'd have to put it in, but it wasn't in there. So we don't have, so you don't, one thing about filling the engineer's description out is you don't make assumptions, right? Like, oh, he probably meant to have one. He didn't have one. So, right. Anyway, so it goes up. So and if the guy puts something on the top and closes the door and presses the down button, I think at the top door, is there an up and a down button? What do you think?
It sounded like there was just a button to go down at the top floor and a button to go up at the bottom floor.
That's right. That's what it sounds like to me too. It sounds like at the top, there's no point having an up button at the top, but there's a down button, right? And it sounds like at the bottom floor, there's an up button because only 2 floors. It sounds like.
A comment that came up in our group was, if you don't have an up button at the top, how do you get it up there if you want to take something down?
Good question. And I think that's something you'd have to bring up with the engineer, right?
Yeah.
Now you got to understand that when you're given a narrative from your supervisor on how to do something, you do it, but you might want to come to him with questions like this. He says, do you realize that, if you're at the up floor and the elevator's at the bottom, how do you get it up? So maybe the down button exists on the top and the bottom floor. It's the same down button. And maybe the up button exists on the top and the bottom floor. It's the same up button. They're in parallel, right? So either up button makes it go up and either down button makes it go down. The up button on the top doesn't do anything different than the up button on the bottom, but it makes it go up. So that might answer that question. That's a good point, right? That's a really good point. And that's something you should think about. And I don't know if anybody think it was clarified in the instructions, whether there was a up on both floors?
The instructions specified 1 on each floor.
Just 1 on each floor. An up button on each floor?
a up button at the ground floor and a down button at the upper floor.
Okay, so again, then so this is room for discussion with your boss, right?
So an elevator like that for the kitchen when I was in the hotel, but the
Yeah.
button is outside that actually inside the elevator because you only put the, for example, dishes like that, you just put it there and then they bring it down to the
Oh, so the button was actually inside the elevator.
outside the elevator. Where's the operator? Because
Oh, I
when
see.
I'm outside, it's just like a window. You only
Right.
put your things there, and then after the button is outside, and then
Yeah.
you press it, and then
Yeah.
go down. And then downstairs is the same. It's just outside.
Yeah,
Yeah, we have like that in the hotel.
yeah, hotels. So they call those dumb waiters, right? I think they call them dumb waiters or service elevator or whatever they call them. Anyways, clearly define how it works. And if the elevator motors are not going, if it's the elevator's not going up and not going down, what's supposed to happen? There was something that happens when it doesn't go up or down.
If you push both buttons at the exact same time and have both doors closed,
Yeah.
it will return to the upper floor.
It defaults to upper. Yes, if you push both up and down. And if it's not going up, if it's at a floor and not moving, something happens. Anybody remember? Let's say it's at the top floor, right? And then there's no power to the motor. There's something else that happens. Anybody can see that?
Well, we looked at it differently there.
Okay.
Because I think we looked at it that the brake was always on. And then when it gets ready to move the motors, then it turns the brake off, and then there would be a delay in the motor start by
Right.
like a half second or something there. So
Yeah.
they could disengage the brake there. But we looked at it as the brake is always on by default.
For safety's sake, right, Andrew? So
Just based on the design description here.
yeah,
But,
that's how I took it too. The brakes are normally on when there's no power, and you disengage the brakes with a solenoid, and you hold them off. And if you should ever lose power in the hotel, the brakes will spring on, right? So the default condition for the brakes is braking, and you have to unbrake them. Does that make sense? And I could see that because you don't want to have all your plates at the top floor and then suddenly you get a blackout for a moment in the elevator and the dumbwaiter crashes to the bottom. The motor will just freewheel and the thing will fall down. You want the brakes to spring on for safety's sake. And then the electrical system takes the brakes off. All right, so we did that. So step 0 of this thing is to, am I sharing my screen? No. Step 0 of every design process is to read the question, make sure you understand the requirements, ask, if you don't understand something, work it out, right? And identify any gaps in understanding. For instance, how many buttons is there an up and down at the top? What happens if the guy's at the top and he wants the elevator, but he's got to run down to push the up button? These things. Identify any gaps before beginning your design. Any errors you make now or any assumptions you make might be bad, right? That might be wired into the system before you realize that's not what you meant to do. Now, step 1 is we have to create an input-output table by identifying each input and every output. So every input and output has to be defined, and we have to create a tag, a little name for each one. And they're usually short little names, 3 letters or so, because we're going to put them into a Boolean expression. We don't want to have a great big name like the up motor, right? Because that's just take up too much space. Just M-up, M-U-P is motor up, that's fine. So we're going to create an input-output table. So let's do that together. You can see this. So let's look at the input outputs ourselves, right? And we're going to come up with common tags that we can all use in our equations. All right, so that way we can all make the same kind of equation. And I know you guys made your own tags, but let's sort of agree on these ones. First one, we have a reversible electric motor, right? So it's an output. So we'll have motor up, we'll call it MUP, and we'll have motor down, MDN. Okay, agreed? So that's one of our outputs. There's another output. What is it?
Brake.
Brakes. Good, Furman. So there's all these switches are held close. Oh, they're doing an input now. That is an output, and it's going to come a little bit later. They're going to mention that later. But now they're doing an input. So the normally open gate switches on the ground floor and the upper floor. So they're normally open. They're held closed by the door. So we'll call gate up, which is going to be the one on the upper floor, and we'll call gate down, which is the one on the ground floor. They're normally open, held closed. Okay. What else do we have? We have a normally closed limit switches at the upper and lower limits of the elevator. So when the elevator is all the way up, the upper one operates, and when it's down, the lower one operates. They're normally closed, and then they're held open by the elevator when it bumps it. So we have a limit switch up, normally closed, and a limit switch ground, LSG we'll call it, for the lower one. Okay. We have an up, normally open push button on the ground floor. It looks like just the one button. So we'll call that, I don't know, up push button, UPB. I'll call it up PB, right? Normally open. And it's nice to just define them normally open, normally closed, in our descriptions, so we know what the heck we're talking about. And we have a down button on the upper floor. And we'll call that D push button. That makes sense? So that's the input. And the last output, I think that Adam mentioned, or Furman, was the brake. There's a brake that holds the elevator in place, right? And you operate it to turn the brake off, right? So when you operate the brakes turn off, right? They don't turn on, they release the brakes when you operate them for safety's sake. So these are the inputs and outputs that we're going to use. So if you go back to, well, you don't have to go back to, but on Jamboard, let's go back to page 1. I've stuck them all here for your reference, and I notice a lot of you have copied these and took them to your engineering page, which is great. That's what I want you to do. So you can copy these. So let's just agree on these symbols for our inputs and outputs. Now, does anybody think there are any other inputs and outputs we've missed according to the narrative? No, I see some chats here. Hold on. Does the unit have motorized doors? Daniel asked. No. Are there safety interlocks on the manual doors? No, doesn't sound like it. Yeah, good opportunity for upselling, he says. Yes, I would probably say so too. You should tell him, you know what, we could put the safeties in there because some guy could stick his hand in there when the elevator's going up. And all right.
Do we need a switch for the door so we know when the door is open and closed?
They have a gate up. Yeah, they have a gate open, gate closed. So yeah, so hopefully the gates will be closed when the motor's going. It won't work if the gate's open. So if the guy opens up the gate, the motor stops and the brakes come on, right? So the elevators might be halfway up, but it'll stop and not cut the guy's arm off anyways. Okay, so we're gonna agree on these inputs and outputs. Okay, so next thing we're going to do is step 3. We're going to do a Boolean expression for every output. So every output we have is going to have its own equation. So we have an output called motor up, and an output called motor down, and an output called brake. So motor up is going to be its own description. So so we're going to have to do a Boolean expression for each output, starting with motor up, motor down, and whatever. So here's what I'd like you to do on the Jamboard. We can do Boolean expressions in a text box, and let me show you how you would do that. So we could say, if we had an expression like, I'm going to just make one up. I'm going to call it out. Out equals, if out equals the not limit switch, you can say limit switch prime. That means not limit switch. And push button 1, or I can push button 1 or push button 2, right? And we can put that in brackets. and that bundles them together, right? And if I want to make push button 1 or not push button 2 active low, I can put a prime right there, right? So we can kind of type our equations out this way. So using brackets to create dominance of that particular function, if I want to group them together, you can use brackets. You can use primes every time you want something to be active low, and you can use not primes if you want them to be active high, right? So using this kind of format, I want you guys to create Boolean expressions for these three outputs. So there's going to be a motor up and a motor down and a brake. And don't forget, the motor up will use all the relevant inputs on it. So the motor up will have all the relevant inputs in its equation, and can also use motor up, motor down on brake as one of the inputs, because the motor up solenoid can have a contact that goes into this control system. So you can use any input you think is necessary, and you can use any output you think is necessary to make it go up and down. You guys understand? So I'm going to put you back in your breakout rooms. You can clear a little spot up there, and you can define equations for each of these guys. I want you to define a motor up equals blah, blah, blah. I want a motor down equals blah, 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 blah. And I want a brake equals blah, 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 blah. Okay. So we're gonna do the equations, and we're gonna use my tags just so we all kind of look the same. And again, this is all on, I put this on Jamboard 1, so you guys can go refer to Jamboard 1 and grab this stuff off it if you like. All right, I'm gonna put you back in your little hidey holes. Any questions before I put you back? All right, go to it, engineers.
Oh, this is good there.
Hey guys, listen, I've got only 2 people in one of my breakout rooms, and I got 4 of you here. Can I take one of you, put you into breakout room 4 with the other group?
Yeah, probably not me, because I'm probably going to step up for a minute here.
All right, no problem. Bernard, can I put you there, Bernard? Bernard?
Sure. Yep.
Can I put you into breakout room, because there's only a couple in there? All right, thank you.
Yep.
And then I just have a question there.
Yes.
Because you had it that the outcome equals these conditions. I always think, is there a specific way that has to be written for that? Because usually I think of it that I have these conditions equals results in this outcome.
Yeah, you can do it
So
that
that's
way
why
if you
we
want.
wrote it that way.
You can have
right?
conditions equal motor up. Yes, that's right.
Yeah.
It's,
Okay.
it's transitive, right?
Yeah, it is transitive there. I didn't know if there was a specific way to write it there.
No, usually I
this
have
is how I
I have
think
the
of it.
output at the right side as well, but it really
Yeah.
doesn't matter. It's just as the
Okay.
sequence of the logic. Sometimes if you have an
Yeah.
or, it doesn't matter whether it's this or that or that or
Yeah.
this, right?
Yeah, we were lucky. We had an absolute pro in the group that kind of walked us through everything. So
Who was that, Andrew?
Andrew, yeah.
All right,
Yeah.
Andrew.
I had to do this because I had to do HVAC system recently.
Oh, this is all kind of familiar to you then.
So it's similar, it's close to that. But we had 4 dampers that they just wanted to control the building there based on where the heat went.
Yeah, we'll do
So
that
I
next.
set up the wiring for that order.
All right. Okay, Bernard, I'll put you in the other room.
Anyway, I'm gonna step up for a bit here for you guys.
Where'd Bernard go? There you go, Bernard. You have a question, Furman?
No, I'm just thinking.
Okay,
Toasting my
you're supposed
brain.
to go into design room 3.
Okay.
Okay.
the pneumatic systems. So they're just using the oil to switch which rail it went to.
Gotcha.
So it's a very similar to the servos that we're going to be working with next.
Okay.
So I got to see a bit of a design there. And then right now I'm just working on a building in Bridgeland, just putting in pipe.
Sorry, Craig, Craig, you're muted.
How's it going? Looks like you got some good equations drawn up there.
Well,
And I-
Andrew's got some good equations.
I like how you put not LSU. That's another way of doing it, right?
Yeah,
And that looks a lot like a Java expression when you say not
Yeah.
bracket.
Well, it's just, it was easier to read there. I like it better than the comma, just
That's
because
fine.
it's,
Yeah, yeah.
it still gets the meaning across.
And I like how you got motor up or motor down equals not brake. I would probably put not bracket motor up or motor down end of bracket equals brake, right?
Okay, yeah.
Because we don't have a not brake, but I guess it is kind of a not brake, isn't it? When you operate it, it's a not brake.
Well, we have it that the brake is at a default on, so when one of them activate, it has to turn the brake off as an active condition there.
Yes, I know.
That's how
That's
I'm
right.
looking at it there.
Yep.
So
It works
it's,
both ways.
yeah, it can be
And
either.
you got a little suggestion on there. Okay, good enough, guys. I'm gonna go check out the other rooms. If anybody has any,
Yeah.
if you guys are moving too fast, kind of work amongst yourselves so everybody kind of understands what's going on.
Yeah.
Okay. All right. Where's my breakout rooms?
Yeah. No,
How's it going, engineering room 2?
Pretty good.
We're just thinking about it.
Yeah, I like what you got here. So motor up equals the gate up is operated and gate down. So both gates are closed, and limit switch up and limit switch up is operated. Yes, because it's pushed open by the door, and the guy presses the push button. Or motor up is operated and gate up.
That was in progress. We were messing with the top one.
Mhm.
We haven't quite figured that out yet.
What you could do, you're trying to seal it, I think. You're trying to latch it, right? So you might do something like motor up equals the up push button, like bracket up push button, or motor up end of bracket, right? So if the guy presses the up push button or the motor is already going up, that everything in the bracket would be true. So you could put up push button.
Like the second line?
Yeah, right where it says, instead of having that second term right there, you could say gate up and gate down and limit switch up and bracket up push button or motor up end of bracket. And that way, if it's going up, then it's going to hold that already up.
So like the second line, the motor down.
Yeah. Anyways, this is good. So think about the logic and see if it makes sense to you guys. All right, and I certainly like your last one, motor up or motor down, not, right? Yes, that certainly works well for the last one. All right, good work. I'm going to go and check the other rooms out.
Kind of like that. Then.
Hi, guys. Oh, you got some good expressions there. So motor up. So you think, you guys, can you hear me?
Yeah, we can.
Okay, so motor up is going to be the up push button or the gate is up. That means if the gate is up, the motor is going to go up, and not the down push button, and limit switch up and not limit switch down and gate down. That might work, right? And brake's kind of complicated. Brake is kind of complicated, but let me just can I just give you some suggestions on the top one, the motor up?
Yes, please.
Okay, so let's try it. Let's just try it together. I'll make my own little thing here, and I'll do it in red. Come on. Motor up equals. So you want the motor to go up when? What is going to trigger the motor to go up, first of all?
First, make sure all the doors are closed.
Okay, so we got to make sure the doors are closed. So motor up happens if the, what do we call them?
Gate switch.
Yeah. Okay, yeah, those are normally open, held closed. They're normally open, held closed. So if the gate upper is operated and the lower
Yeah.
gate is operated, right?
Yeah.
Yeah, that means they're both closed. Good. And what about the
And
upper,
the
upper limit
switch.
switch? Do you want,
Up button, UPB switch.
so we want this to be limit switch upper would be, it's normally closed, and then it's going to be held open when it gets to the top, right?
Limit switch, yeah.
So and the limit switch upper should be closed.
Should be closed.
Sure, yeah, as soon as it's open, it'll stop. That's good. So what about the next one? Limit switch ground. Do we care on the ground when it's going up, whether it's open or closed? Because it'll be both, right?
Yeah.
It'll be closed when it's down. It'll be open when it's going up. So either way, up or down, it doesn't matter. So limit switch ground doesn't come into it. So I'm not going to even put a limit switch ground there.
Okay.
That makes sense?
Yeah.
I could put limit switch ground or not limit switch ground like that, right? But that ends up being one, or sorry, not limit switch ground. But that ends up, it's both either true or false, right? Doesn't matter. So this whole expression, it's just doesn't matter. So we don't
Can
need
you
limit.
write it down on Jamboard? Okay.
Yep. Are you on? This is Jamboard for room 3, right?
Yeah.
All right. So you see I'm doing the red one. You can see my red one, right? Page 4. Okay. What about up push button? So the up push button has to be pressed, right?
Yeah.
So the up push button has to be pressed, right? Or if the motor is already going up, you want it to keep going up, right? So you can see up push button, or it's already going up, right? And this will keep it going up even after you take your finger off the up push button. That makes sense?
Yeah.
Mm-hmm. And what if the guy presses the down push button? Does it affect it going up?
Reset.
So it's going up and the guy up presses the down button, does that affect it?
Yeah.
I don't think it does. The default is up, right?
Yeah.
So if he pushes the up push down push button, it shouldn't affect it. So it's the down push button or not down push button. It's true. So I think this works pretty good for making it go up.
We cannot see it.
Yeah, we cannot see your work. That's why.
You can't see my work?
Yeah.
Yes.
I thought you said you could. I'm on page
I
4.
couldn't. Yeah, you're
Yeah,
on page 4, but
page-
we couldn't see.
Oh,
Now it shows.
I have to
Now-
finish that. I'm sorry, guys.
Yeah.
I thought it showed up as as I was typing it.
Okay.
Okay, now it shows up. Okay, good. So that kind of makes sense.
Yeah.
Okay. And so see if you can figure out what motor down is. Now, I'll give you guys a couple
What
minutes.
about the brake? When did you?
Okay, well,
switch-
what about the brake? Let's do the brake then. So I'm gonna do another one for brake.
No, I mean when you turn on the up button, it should trigger also the brake, right?
Well, let's talk about the brake. So when does the brake happen? So the brake equals,
When motor is on, brake is
yes, when either motor is on, right?
yeah.
When motor up or motor down is on, the brake will be operated, and the brake is the thing. When your brake is operated, it's kind of a brake release, isn't it?
Yeah, it
Turns the
really
brakes off. So when you say brake, it's kind of like a brake release.
yeah.
So the brake will be on if motor up or motor down is activated. So you don't have to put all the other logic in there. If the motor's going, take the brakes off.
Okay.
So if you put on motor up, the brake will be off. If you put on motor down, the brake will be off.
Okay.
Okay, good. So think about motor down a little bit, and I'm going to go check on the other group.
Okay, thank you.
All righty, good work, you guys. Hey, Chris. How's it going?
I think good, maybe.
Okay, let's have a look. Can I have a look at your two equations here? I can see you got them there. So motor up. Jessica, can you hear me? Is she there?
Yeah, I don't know. She doesn't say anything.
Jessica?
Assume she's away.
Hmm.
I'm here.
Okay,
No.
good. So let's have a look at motor up. So motor up happens if the up push button is pushed and the limit switch upper. So the limit switch upper is normally closed, right? So that means it's normally closed. That means we haven't operated yet. So I think it should be limit switch upper and not limit switch upper, right?
Right.
So I think it should be up push button and limit switch upper because it's normally closed anyways. And gate up and gate down, I agree with those. Those are good. Now, the only thing I would suggest you guys is once it goes up, you want it to keep it going up, right?
Right.
So I would think, let me just do another one, another thing right here. So, and I'll do it in red. Come on, sorry. This is kind of a strange interface. There we go. There, can you see that?
Yeah.
So I would say if you did all of what you did be there before, but you said the up push button or the motor is already going up and everything else. Something like that, right?
Oh, okay.
That would mean you press the up button, the motor will start going up, and then this motor up term will turn on and it will continue to go up. Right? So this right here seals it. This thing seals it. That makes sense? And then
What's UPM?
Up, MUP, motor up.
Oh, motor up.
Motor up. Oh, sorry. Up UPB. Sorry, that should be UPB. Yeah.
Okay.
Sorry, you're right. It's meant to be UPB. Let me if I can. Up push button. Oops. Yeah, up PB. Yeah. Good question. Right. So you're on the right track, you guys.
Okay, so that just makes it keep going when it's on.
Yeah, it seals it because you
Right.
push the up button and that'll make it start. That'll turn motor up on, assuming the other conditions are all right.
Mhm.
So motor up comes on and then it will turn the MUP component on. It'll turn this MUP component on and then that'll keep it going, right? Until it hits the limit switch at the top,
Oh, okay.
right?
That makes sense. Thank you.
Yeah, yeah. So that's how so we're using an output here, the MUP output. We're using the MUP output to seal it. So an output is being used as an input to our formula.
Right.
Cool. All right. I'm going to bring you guys back into the room in a few minutes. All right.
Okay.
Okay.
All right.
Okay. Is everybody back? I think. Oh, no. I guess there's still breakout rooms.
Craig,
Yes,
our
sir.
our group was playing with an online PLC simulator. We found a free one, but do you have any suggestions for?
Oh, absolutely.
Okay, because I think I could benefit from, just sitting down and playing with this.
Oh, there is a really good one, and there's actually a SATE license you can get. If you have a VPN into SATE, you can use the free license. Let me share my screen with you now. A PLC simulator, one of the best and most popular in the market. And in fact, it's so popular that even though it's like really dated because it looks like something out of Windows 95, right? It hasn't been beaten as far as it goes, and it's made in Canada, and it's called Logix Pro. So this is it's not free. It's like $40, but it's not a $40 a month or $40 a year. It's $40 forever on this thing, and it has all kinds of great simulations. It lets you do ladder logic. It lets you do all the functions that you guys are going to be doing in your PLC. So when we talk about PLCs, we're going to be using RS Logix as our environment. Logix Pro mimics it exactly. So let me show you here. So I'm going to Control-C. I'll paste this into. I'm going to paste this into your chat. And I'm not in, you don't have to buy this. This is just my own personal suggestion. But here it is right here. And you got all of these simulations you can actually program to, like there's the garage, the basic IO. This is the garage door simulator. And it's very, if you're doing that in your lab class, which one are you doing? Are you doing the garage door? Are you doing the submarine? Do you guys know?
I believe it's the door.
Okay, so it's the garage door, and this is it. This is the garage door. Silo simulator for doing conveyor belts, filling up boxes. Batch simulator for filling up a batch and stirring it and pumping it, filling it full and closed. All active simulators. And there's also a bottle line simulator, a dual compressor simulator, filling pop bottles. It's really, really involved, super complicated pop bottle simulator for you to figure out. There's an elevator simulator too. So I would if you like solving puzzles and you want to learn how PLC programming works, if you don't go into the automation stream, spend your $50 or $40 or whatever it costs and get this Logix Pro. It's really a neat little program. And I do apologize for the fact that, it's got like the paper clip and the little wizard they used to have back in the 80s and 90s. The little help thing pops up. That just shows how old it is. But this guy who invented this thing is making millions off it because nobody has made a better one, right? That works so more like RS Logix. Does that kind of answer your question? Yeah. So yeah. Oh, and you can download it, and there's a 15-day free trial. And I don't want to talk about it because it's not fair to talk about it, but yeah, and I recommend it. I recommend it, but of course I don't insist on it. But the 15-day free trial, we can have a lot of fun when we're doing our Logix simulation. Okay, so let's talk about what we need to do now. So we want to create our Boolean expression for each output. You guys all had really good ideas on how to solve that. And you can see we all did pretty good Boolean expressions. Let me show you the jam boards. So there's room one. See, they got the motor up, they got the motor down. They did a second motor up. They kind of changed things around, and they did one for the brake. There's the brake over here. So they got their first crack at it. Design room two, they did a motor up, motor down, and brake, right? There's design group 3 and design group 4 all put together expressions. Now, they might work, they might not. I'm not gonna, we'll find out if they work or not when we wire the thing up, when we have to go back and adjust these. So it's very common. You do the Boolean expression, it looked good. You wire it up, suddenly it doesn't look so good, right? Then you have to go back and change your expression and change your wiring. So you might have issues or not. But let's look at how I did these things. I'm going to solve it. So we've created a Boolean expression for each output. So let's look at the first criterion. The elevator motor will turn on upwards if the up button is pressed, if both gates are closed until it reaches the upper travel limit switch. So motor up will turn upwards if the up button is pushed, up push button, and both gates are closed, right? And they're normally open gates. So when they're closed, sorry, they're not, so when they're closed, they're active. So there'll be active high signals until it reaches the upper travel limit, right? And that'll make it go up as long as you're pressing the button. But we want to be able to make it sealed, latched to go up, right? So we'll leave motor up for now. This will work as long as you're pressing the up button. When you release it, it'll stop the up motion. So it's not quite good yet, not quite done. The motor will go down if the down button is pressed, if both gates are closed, until it reaches the lower limit switch, right? That's the equation for the down button. But once in motion, if the button can be released and all other button presses are ignored. So once it's going up, it should keep going up. So once in motion, we put in a motor up or a push button. So once, and all other key presses are ignored. So it's probably a good idea to say not motor down. So you're not going to accept the motor down. Okay. And similarly, motor down is motor down and down push button and not motor up. Right. Now this criterion here, in the event that the elevator is in mid position, so it's halfway up and it's not moving and the gates are both closed and both the up and the down air buttons are pressed simultaneously by the guys on the 2 floors, in that rare instance, the elevator will default to going up. Okay. So all we have to do there is say our motor down does not, the motor down will only seal if the guy didn't press motor up. So here we're putting in the not motor up. He pressed the down push button and not the up push button, right? If he did press the up push button, this equation would fail, right? So the motor down would not happen if he pressed the up push button. And I'm not going to put that in the up push button, so it'll have the default. It'll go up. Motor down, motor up, or up push button will make it go up, even if the guy presses the down push button, because it's not in that equation. Any feedback or questions on that? So this is my interpretation of the instruction, a really complete version of the instruction.
So that bottom one though wouldn't work because it's prerequisite that both buttons are pushed at the same time for it to go up.
Motor down?
And both buttons are pressed at exactly the same time, the elevator will move up. So you can't say prerequisite that it doesn't get pushed at the same time.
Yes, you can. So what happens here, if it's not pressed, then it's active high, right? So if you don't press the up push button, where's my pen?
Because your formula there says that only one button is pushed, right?
The bottom one or the top one? The motor, we're talking about motor down?
Bottom one, yeah.
Okay, so the bottom down one means we have to press the down push button, and we have to not press the up push button. So the criterion is
instruction state, right? Because the instruction state, they both need to be pressed.
If both are pressed, we want it to fail, right? So what this is doing is, if both of them are pressed, this is not true. So the motor down cannot happen. So if both of them are pressed.
I'm sorry. I saw motor down. I'm sorry. I thought this was the motor up and you were doing a different one. I misunderstood. Yeah, it's correct. Sorry.
Okay, good. It's possible. And this is what you want to do. You want to talk about the logic and work out any problems with it, because maybe I blew it. Maybe you're right, right?
You did not. It's 100% correct.
So this is going to kill the motor down if he presses both buttons, right? But we don't have it in the motor up. So if he presses both buttons, then that one's going to be true and it's going to go up, and then it's going to make that one true, and it's going to keep going up until it bumps into the upper limit switch and opens it. Yeah. And we've also got, if it's this term right here, this is just making sure that you don't have motor up and motor down at the same time. So if you got a motor down going on, you can't go, the motor up can't be on at the same time, because one thing about motors is you can't tell them to go up and down at the same time. They'll burn out, right? It'll just burn them out. You're going to find this in the garage door opener, that when you're going up, one of the conditions is if it's going up, it can't go down at the same time. If you tell it to go up and down at the same time, it'll catch on fire in spectacular fashion. So, okay, so this little thing here makes sure that they both don't happen. Okay, what's another term? The brake will disengage if the motor is on. All right, so there's the brake equals, it'll activate the brake output to disengage the brake if the motor's on. So really, it says brake, but it's actually more like I would call it like a brake release. A brake release may be more descriptive of this thing, because it's not really a brake. I think Adam's group called it a not brake, right? An unbrake. I would call it a brake release is what it really is. Brake release equals not motor up and not motor down, right? So that's brake motor up. So if you don't press, if motor up is not going and motor down is not going, brake it, right? Or the other way you could say this is you could also do it this way. Brake equals motor up or motor down, not. Right? You could do it this way. Brake is motor up, or it's not motor up or motor down. Okay, that's another option for brake. It's the same thing. Exactly the same logic. Okay, any questions about that? So that was an example of how we do the design circuit. Step, go back to the beginning. Step 0. Go back to the end here. So many steps. So step 0 is you got to really understand the problem and define all of your inputs and all of your outputs and know when they operate. Know when they're operated, when they're released, when the active low, active high, limit switches normally close. You got to really understand all the inputs, and you got to understand what the directions are, what the narrative describes for you, right? Step 2, you build a Boolean expression for each output, motor up, motor down, and etc. Right? Once you have the Boolean expression, you can create a wiring diagram to match those things. So for instance, I'm going to do it right here on my little screen. But once I have the Boolean expression, it's very easy to do the ladder diagram. So I'm going to start with, let's start with the top one, motor up. So there's my motor up right there. And motor up equals the up push button. So we can do the symbol up push button, or motor up, and the gate up. So the gate up would be our limit switch. Gate up is, I guess, a limit switch held closed is gate up and not gate down. Gate down, so that's a limit switch held, normally open, held closed, and a limit switch up. Limit switch upper, right? And not motor down. Not motor down, right? So that is the circuit that describes the top equation. So if I press, let me go to a different color here. If I press the up push button, the current's going to go there. My gate is closed, so it's going to go through there. My gate down is closed. My down gate is closed, so it's going to go there. My limit switch upper is, is normally closed, so I haven't hit the top yet, so it's going to go through there. The motor down is not going, so it's going to go through there. So that's going to make my motor up come on. All right. And once the motor up comes on, then this is going to close, and I have a shunt around the up push button, and it's going to keep going up. And it's going to keep going up until the upper limit switch upper opens and kills the whole thing, right? So that's how I would take my Boolean expression and turn it into an equation. Does that make sense to you guys? All right. Remember, everything that's ORed, I put in parallel. Everything that's ANDed, I put in series. Everything that's active low, I'll use a normally closed switch. And everything that's active open, I'll use a normally open switch. And these are all normally open switches, held closed, but they're normally open switches. All right, held closed. All right, so you should be able to build an equation, and the equation should be able to turn you into a beautiful little circuit, right? Any questions on that rung? Well, the other one is motor down, right? So motor down, let's try it. It's going to start off with a three-piece thing. It's going to have the down push button, and it's going to have the not up push button. So I'm going to do a normally closed up push button, right? Normally closed up push button, and it's going to be ORed with the motor down. So this is my motor down right here. And what else we got? We got a gate down. So here we go. Limit switch, held closed, normally open, held closed. That's my upper gate is down. And then this is my limit switch, normally closed, normally open, held closed. There's my gate up. And limit switch, the bottom limit switch, right? So actually, yeah, that's right. I would probably actually put this on the top because it's going to be pushed open by the door. So when the elevator comes down, it'll hit it. The elevator is going to hit it from the top. So I'm going to put it off the top of this thing and not motor up. Not motor up. So the motor down can't happen if the motor is going up. And that motor down right there seals it. So again, to follow through, so if the guy presses, let's say, and not push button up. So not push button up. Yeah. So if the guy presses the down push button, it's going to go through there, going to go through all the limit switches, going to go through the motor up, which is not operating, operate the down, and go through here and seal it like that. And oh, wait a second. I did do something wrong. Anybody see what I did wrong? It's got to do with the up push button. Anybody see what I did?
You didn't put it in series with the down push button.
Absolutely. See, I did it in parallel like it was an OR, right? Oops. See, that doesn't, I looked at the logic and says, wait a second, that's not going to happen. So yeah, I got to take this out. That's wrong. I got to take that out. It's actually in series. The up push button goes right in, do it in red. The up push button goes right in there. Come on, red, pen, that. Not up push button. So if the down push button happens and the not and the up push button is normally closed because it's a not up push button, that's what's going to give me the circuit working, right? And so I can go straight from my equation right to my circuit. big mistake as an engineering technologist is to look at a problem and go straight to the circuit, right? I'll just build it right from the circuit. You don't. You build it from the formula. You always start with the formula. You can move into the circuit from the formula. And the cool thing about the formula is if you decide you don't want to solve it electrically, you can take the same formula, put it into a PLC, and it'll work. And if you don't want to solve it with an Arduino, you can put the same formula into an Arduino and it'll work. Or you can put it into a Raspberry Pi, or you can put it into any computer system you want. But the Boolean expression that we described here is the mathematical description of the control system, right? So this is the correct way of designing a control system. Understand the problem, define the inputs and outputs, build the Boolean expression that works with those inputs and outputs, and then turn it into whatever it is you're going to solve it with. In our case, ladder diagrams. So how you guys doing? Is this making sense?
Well, that remains to be seen, right?
You're going to find out in your lab. All right, cool. As I say, this comes with practice, right? And practice is the best way of doing this. But as I say, you can fumble through and throw switches in series and parallel and try to solve a problem. And if it's a simple problem, you might make it work, right? But that ain't how we do it. That's not the engineering design approach for control systems. So you guys have a lab, don't you, coming up? And I understand it's going to be the garage door, I think, unless Chris Taggart's told you otherwise. You sure it's the garage door, right?
As far as I know, yeah.
All right, cool.
He told me a garage door, yes.
Okay, good. Okay, so here's your garage door, guys. Here's your garage door, and you have lights. You have lights here, ajar, open and shut lights. There's pilot lights. You have an open push button, a close push button, and a stop push button, right? That will open and close it, obviously. And if you want to stop it in the middle, there's a stop. But it hasn't been defined yet how they're reacting to each other because we haven't read the description. We have, this is one of those roll styles. So you can imagine this is a big cylindrical roll that rolls up the garage door. Do you understand? It's not like a flat one that opens up. It's like a rolling one. And as it rolls upwards into its little roll, this limit switch is held closed. It's a normally open limit switch held closed by the door. And when the door reaches the top, it will spring open. Are you good with that? Make sense? You also have another limit switch down here, which is a normally open limit switch waiting for the door to hit it. So when the door goes down and hits that limit switch, it will close it. Right? So we have two limit switches, both normally open. One of them is held closed by the door until it's all the way open. We have a motor up and a motor down as well. That'll make the motor go up and the motor go down, and you get fired if you operate them both at the same time. It's very spectacular. The flames will come out of this thing and the fire alarms go off, right? So you don't operate motor up and motor down at the same time. So this is the inputs and outputs. So you need to define for your circuit. Are we okay? And the only thing also, the open and close push buttons, those are normally open push buttons. The stop push button, is a normally closed push button, right? It just happens to be a normally closed. Why? Because safety, right? Normally closed is always safer. If it fails, it'll fail to the safest condition, fail to safe, we call it. All right, any questions about all those inputs and outputs? And don't worry about that, we don't need that for this. You guys all good with this? So there's our input.
Conceptually, anyway.
Yep. Yeah. So there's our inputs: motor up, motor down, open pilot light, and I've even give you symbols you can use so we're all on the same page, right? And there's the outputs: motor up, motor down, pilot light open, pilot light shut, pilot light ajar, right? And then there's the symbols you can use for the inputs, the open push button, the close push button, the stop momentary contact push button, the limit switch 1 and limit switch 2. There's my inputs. Okay, so that's what you're working with. And there's going to be an equation for each one of these. That's going to equal something, 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 right? Blah, de, blah, de, blah. And these expressions are going to be made up of whatever inputs are relevant, and maybe some of your outputs can be put into your equation too, right? Like for sealing purposes and things, right? So there's three, oops, I think we did it in the past, is there are like 3 variants of it. One's kind of medium, one's harder, right? More difficult, and you have to figure out how to actually solve that problem. But let's look at the top one to see if we can understand it. So I'll just read this to you right now. It says, the door includes a reversible motor and blah, 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 blah. In this exercise, the open and close buttons will be used to control the movement of the door, obviously. The movement will not be maintained while either switch is released. That means if I release an open and close, it will stop opening and closing. So you got to hold the button down while it opens. So you don't need to have a stop switch, because you just take your finger off the open button and it'll stop all by itself. This is the simple version of this circuit, right? However, all other inputs and outputs are employed. So let's see what we have here. Let's look at our descriptions. Okay, if you press the open button, it's going to go up unless it's already all the way open, right? We'll continue as long as the switch is held down. Once the switch is released, or the limit switch 1 releases, the door movement will stop. Easy. It goes up until the limit switch is at the top operates. Pressing the close switch, well, does the opposite. It closes the door until it touches the bottom limit switch, till it hits the bottom limit switch and closes it. So that's pretty simple. If the door is already fully open, pressing the open button doesn't do anything. If the door is already closed, pressing the close button doesn't do anything, which is good. We don't want to burn our poor motor out. If you press open and close at the same time because you're an idiot, right? Well, it won't operate motor up and motor down at the same time, because that's bad. It will burn out the motor controllers. So neither motor will operate if you're going to play the turkey and press both buttons. And I guarantee if there's 2 buttons on there, somebody's going to try pressing them both to see what happens, right? There's always one in every shop. If the open lamp will be illuminated if the door is fully open. The shut lamp will be illuminated if the door is fully closed. So exercise 1, pretty easy, right? If you look in your lab, you'll have an exercise 2 as well. Exercise 2 is you press the open button, you release it, it'll go all the way up until it stops, right? And if you press stop, it'll quit. You press the down button, it'll go all the way down until it hits the bottom, unless you hit stop. Stop will stop it. So the second exercise is a little more complicated. I think the second exercise also has the ajar light. So if the door is opening or closing or in the middle, the ajar light's on. So that tells the truck not to try to go through the door because it's not fully open yet. It's not fully closed. So that's the ajar. That's exercise 2. Exercise 3 gets into really cool flashing lights and all kinds of more complicated things you guys can wrestle with. So that's exercise 3. So this is going to be your challenge in your lab class, is to design the Boolean expressions for all of those guys and come up with a solution, build a ladder diagram, build a ladder schematic, and wire it up on the EMSI trainer. And we're going to use lights to represent motor up and lights to represent motor down, because I never did build a little electric motor that goes up and down, but I think I should. That'd be fun.
Don't they have little motors in the labs like that you can plug into?
No, they don't. No. Some guys, just for fun, will hook their motor up and motor down into pneumatics, right? And they use a cylinder to move the motor up and motor down. But that's beyond the scope. So right now we're just going to use a motor up light and a motor down light. two separate lights. And I think if Chris is running things the way we usually do, he expects you to come in with a plan. He expects you to come in with all the formulas ready to go, right? And he'll check you off. And if you don't have the formulas at the beginning of lab class, you're going to lose points, a good chunk of points. All right. So does anybody have any questions about what's expected of them?
So basically come to lab with all the stuff done already.
Don't come to lab unprepared. If you come to lab unprepared, number one, you're going to lose points. Number two, if you spend half your lab trying to figure out what the logic is, you're not going to get the lab done, right? So definitely come prepared. If you come with a Boolean expression that doesn't work, well, at least you got something to start with. And maybe he'll help you with the expression, or maybe he'll let you wire it up and then you realize, oh yeah, right, I forgot about that. And you'll change the expression and change your circuit and rewire it. So that's perfectly fine. That happens all the time. So it's valid to write down an equation that maybe doesn't work, but at least you took a shot at it. So we expect failure. You know, it's going to happen. You're going to have some frustration. It's going to be a part of the learning process. All right. Does anybody have any other questions about this? No, you guys good? 1, 2, 3, 4, 5, 6, 7, 8. There's only 9 of you left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of you. How about that?
How many were supposed?
Oh, we got about 21 in this class, so. But I'm sure, what did Chris tell you specifically? Did he give you instructions on the lab? Anybody?
He just mentioned to me that the next time we're going to make a door, but he didn't told us that we have to have a ready. He didn't say that we have to be ready.
All right. Well, he's the lab instructor, and you know, you can deal with whatever he tells you to do. When I'm the lab instructor, I want you guys to come in prepared, right? And that you've got an area in your the workbook we gave you to actually do the preparation. And if you don't do the preparation, you come into class cold, it's going to be harder. And of course, you can work with your partner, right? You got a lab partner probably. Do you have a lab partners? Yeah.
Yes.
Yeah,
Yes.
we've been assigned to partners.
Yeah, so you can work with your lab partners, get together with them, you know, and hammer this out beforehand. You'll enjoy the lab a lot more. I think it's 2 weeks, a 2-week lab. I think you guys get to work on this one, as I recall. All right, guys. So that's it. 9 o'clock. Next week we'll talk about the midterm exam, and the week after that we'll have our midterm, and then we're on to pneumatics. The week after that we'll cover pneumatics as well. But during the midterm, there's no other new material in that class. Okay.
Okay, thank you. Bye.
Hey, no problem, Furman. You guys take care.
Thank you very much.
I'll be the last person off if anybody has any questions. Night, Jessica.